Alright, 1.5, functions and logarithms. Okay, I'm going to write down the first definition. A function f of x is one-to-one on a domain D if f of a does not equal f of b whenever a does not equal b. Now, if you guys remember, a function cannot have two y values for the same x value. A one-to-one function cannot have any two x values for the same y value. Okay? So, one way to determine whether or not functions are one-to-one is with the horizontal line test. You guys hopefully remember that the absolute value of x looks something like this. Okay. If you were to use the horizontal line test here, it intersects the graph twice. So this function is not one-to-one. Remember, the vertical line test determines whether or not a certain relation is a function. In this case, it is a function, but it's not one-to-one. Okay? Alright. And root x looks like this. This one does pass the horizontal line test. Wherever you draw your horizontal lines, it's only going to hit the graph once. Okay? So, this one is one-to-one. This one's not one-to-one. Okay, you guys try this one. Alright, this is what you guys should have gotten. Writing inverse f as a function of x. Alright, if you're trying to find the inverse of a function, you're basically going to solve the equation for x in terms of y. And then you just switch the x and y. I think depending on what textbook you have, some textbooks teach you to switch x and y first and then solve for y in terms of x. It's pretty much the same thing. For example, here we have y equals negative 2x plus 4. I'm going to solve for x. So subtract 4 from both sides. So I got y minus 4 equals negative 2x. Divide by negative 2, divide by negative 2. So now I've got negative y over 2 plus 2, because negative 4 divided by negative 2 is positive 2, equals x. Now I'm going to switch my x and y. So I've got y equals negative x over 2 plus 2. I also moved this over there so just looks a little bit nicer. Okay? So, inverse f of x equals negative x over 2 plus 2. Alright, go ahead and try this one. Alright, you guys should have something that looks like something like this. For this example, I switched x and y at the beginning just to show you guys that you can really do it either way, whichever way you feel more comfortable with. I switched x and y, then I subtracted 3, then I divided by 2, and this is what I got. Now, this is a good way to check your work if you're not really sure if you got the right answer. F of its inverse, if you compose those two functions, you should end up with x at the end. Either way you do it. F of inverse f or inverse f of f, you should get x both ways. If you did it right, that's what you should get. So I did it over here, and then I did it the other way. I got x both times, so this looks like it's the inverse. Oh, I guess I had some more space. Oh well. Alright, example 3. Graph the one-to-one function f of x equals x squared for x is greater than 0. Okay. It's important that they mention that because the graph of x squared, the whole thing is actually not one-to-one. It looks like this, and obviously if you did the horizontal line test, it would intersect twice. But they're telling us they're just taking the positive when x is greater than 0. Okay? It's inverse, okay, and the line y equals x. Alright. Let's find the inverse of this function. So I've got y equals x squared. I'll do it the other way this time. I've got x equals y squared. I'm going to take the square root of both sides. Y equals positive negative root x, but remember we're only dealing when x is greater than 0, so y equals positive root x. Okay? So, the square root of x, let me use a different color, looks like this. Okay? Now, if I graph the line y equals x, the line y equals x looks like this. And what you're meant to see is that if you graph the inverse correctly, it should be symmetrical across that diagonal line. So you guys see how this and this are symmetrical of each other. Okay? That's good. That's what it's supposed to be. Alright? Okay, express the inverse of f as a function of x. I'll do that down here. Inverse f of x equals root x. There we go. Okay, use parametric graphing to graph f inverse f and y equals x. Alright. Alright, well, first things first, let's grab the calculator. M 2 to the negative x. Looks like that. Alright. I'm also going to graph the line y equals x. So, when we find the inverse, it should be symmetrical across this diagonal line. So let's go ahead and do this. I've got y equals 2 to the negative x. I'm going to have to use logs here. Oops, wrong button. I'm going to change colors. Let's see here. Let's use green. If you guys remember the log rule, it looks something like this. If you have b to the y equals x, then you have log base b of x equals y. That's the basic rule of logs. Okay, so this is what we have. I could switch it around to make it a little bit easier. So this is what I have right now. I'm going to change it into this. So I've got log base 2 of y equals negative x. I multiply both sides by negative 1. So now I've got negative log base 2 y equals x. And then I can switch my x and my y. I'm going to put my y over here. This is my inverse function. So let's plug that into the calculator and see what happens. Alright. So, now, we can't make a log base 2. So what I'm going to do is I'm going to use the change of base formula. So I'm going to have ln of x divided by ln of 2, which is essentially the same thing as what I have here. And graph. Alright, so as you can see, this is the line of symmetry. It's symmetric across diagonally. If you guys don't remember the change of base formula, I could write that down for you. Here it is. Different shade of green. I meant to use the same one. Change of base. You can have, if you have log base a of b, this is the same as log of b over log of a, or natural log of b over natural log of a. Same thing. Alright. Oh, let me box this. Looks very colorful. Alright. Base of a logarithm function. Let me write this down. The base a logarithm function, y equals log base a x, is the inverse of the base a exponential function, y equals a to the x. This is when a is greater than 0 and a does not equal 1. So this and this are inverses of each other. Alright, inverse property. Alright. With base a, a to the log base a x power equals x. And log base a of a to the x power also equals x. This is when a is greater than 1 and x is greater than 0. Okay, that's because this and this cancel each other out. This and this cancel each other out. Also, e to the ln of x power equals x because these cancel out. And ln of e to the x cancel each other out. Or ln and e cancel each other out, and you end up with x over here also. And this is when x is greater than 0. Okay, so if we were to go about solving for x, there it is. To get rid of this ln, I'm going to take e of both sides. So that cancels out, and I'm left with x equals e to the 3t plus 5. Done. Over here, to get rid of the e, I'm going to use ln. So I have 2x equals ln of 10 divided by 2. Oop, this should be a 10 over here. My bad. So x equals ln of 10 over 2. And if I pull out the calculator, so I've got ln of 10 divided by 2. So approximately 1.15. Ish. Alright, you guys go ahead and try these.
Well,
you know what? There's actually a mistake on this one.
my guess is you are at the wrong place.
There shouldn't be a t here. So it just equals 2. Alright, go ahead and try it now. Alright, these are the answers you guys should have gotten. Okay? It says support your answer graphically. What you would want to do there is, for this one, you could set this equal to 0 and graph it, and then see if it hits that your 0 is at this point here. This one, not really sure. If you just give me this, that's fine. Alright, properties of logarithms. I kind of wrote these earlier, but I'll write them again. Alright, this is kind of review. The product rule, if you're multiplying two things inside a log, you can expand it with addition. If you're dividing, you can expand it with subtraction. And the power rule, you can move the exponent out in front. The change of base formula we kind of already went over. Alright, graph f of x equals log base 2. Alright, let's get the calculator out. Alright, y equals... Alright, let me write this down first. You can't do a log base 2, so what I'm going to do is I'm going to change of base it. This is ln of x over ln of 2. This we can graph on a calculator, so let's go ahead and do that. So I've got ln of x over ln of 2. Graph. There we go. Something like that. Alright. Draw the graph of this and determine the domain and range of the function. Go ahead and try that. And then when you think you have it, hit play. Alright, this is what you guys should have gotten. Okay, example 6. Sarah invests $1,000 in an account that earns 5.25% interest compounded annually. How long will it take the account to reach $2,500? Alright, let me change colors. Okay, so the amount in the account at any time t in years is 1,000 because that's the principal times 1.0252. 1, this is basically 1 plus the interest. So 1 plus 0.025, actually I could write that out.